A future conflict might not start with an attack on a military base. It could begin with the disruption of a satellite. Today, satellites carry the communications, navigation, intelligence, missile warning, and precision targeting that connect every aircraft, ship, and soldier on Earth. Space has become the new battlefield, and the more we depend on these networks, the more valuable and more vulnerable they become. On October 4, 1957, the Soviet Union launched Sputnik 1. The world heard a simple radio beep, but military planners saw a demonstration of ballistic missile capability. The R-7 rocket that carried the satellite was an intercontinental weapon capable of delivering a nuclear warhead to other continents. 3 years later, on May 1, 1960, a Soviet surface-to-air missile shot down an American U-2 spy plane, exposing the vulnerability of high-altitude overflights. The incident accelerated the push into orbit. Satellites, immune to atmospheric air defenses, became the primary platforms for strategic reconnaissance. The United States focused on its classified Corona program. On August 11, 1960, Discoverer 13 returned the first recovered film capsule from orbit. The Soviet Union countered with the Zenit program, launching Cosmos 4 in 1962. By providing direct observation of missile sites and military movements, these early spacecraft reduced strategic uncertainty. Space exploration and military competition did not develop separately. They were born together. On January 27, 1967, nations opened the Outer Space Treaty for signature, establishing the first major legal framework for orbit. Entering into force on October 10th, the agreement aimed to limit conflict. Under Article 4, countries could not place nuclear weapons or weapons of mass destruction in orbit, nor could they build military bases on celestial bodies like the Moon. But the treaty did not outlaw military activity around Earth. It drew a clear distinction between militarization and weaponization. Militarization, using space infrastructure like reconnaissance, navigation, and communication satellites to support forces on the ground, remained entirely legal. Weaponization, the placement of offensive weapons in orbit, was banned. This legal boundary allowed military satellites to multiply, cementing orbit as an essential backbone for military power. Today, 4 global systems dominate satellite navigation: the American GPS, Russian GLONASS, European Galileo, and Chinese Beidou. These networks provide positioning, navigation, and timing data that modern militaries require to operate. Without this data, precision-guided munitions miss their targets, logistics networks stall, and ships, aircraft, and ground troops lose their bearings. Besides navigation, orbital networks serve as the primary link for military communications, connecting commanders directly to remote forces across the globe. Above the Earth, intelligence and reconnaissance satellites track troop movements in real time. Infrared early warning systems monitor heat signatures to detect missile launches instantly, while weather satellites guide operational planning on the ground. This vast, space-supported network links sensors directly to weapons and decision-makers. It multiplies military capability, but it also creates a serious vulnerability. A force that relies entirely on space assets risks blindness if those systems stop working. A state does not need to destroy a satellite physically to disable its military value. A spectrum of quiet options can neutralize space systems from thousands of miles away. Jamming floods a receiver with noise, drowning out the weak orbital signal. Spoofing broadcasts false data, tricking navigation computers into calculating wrong positions. Cyber attacks can target ground stations, command links, or receiver firmware. Taking control of data networks. Laser systems can temporarily interfere with or permanently blind reconnaissance sensors. These methods form an escalation ladder, starting with low visibility interference and ending with physical destruction. The primary challenge is attribution. When an orbital signal fails, operators cannot easily determine the cause. A sudden outage might be a solar storm, a temporary mechanical glitch, or a deliberate act of war. This uncertainty forces commanders to interpret ambiguous events, where a simple technical failure can be misread as a targeted attack. The next step on the ladder is physical destruction, but kinetic anti-satellite weapons create consequences that cannot be contained. During the Cold War, the United States and the Soviet Union pioneered these technologies, testing direct descent missiles and co-orbital interceptors. In the 21st century, new players proved their own capabilities. On January 11, 2007, China destroyed its defunct Fengyun 1C weather satellite at an altitude of 865 kilometers. The impact shattered the spacecraft into the largest recorded debris cloud in history, generating over 3,000 trackable fragments. Because of the high altitude, these pieces will remain in orbit for decades, crossing international paths and threatening civilian and military satellites from uninvolved nations. Seeking to limit long-term pollution, India conducted its 2019 Mission Shakti test at a lower altitude of 283 kilometers, allowing most fragments to decay rapidly. Yet even controlled tests trigger reactions. These capabilities show adversaries that their space infrastructure is vulnerable, pushing rivals to invest heavily in satellite hardening, orbital redundancy, rapid replacement, and defensive countermeasures. The full-scale invasion of Ukraine in February 2022 showed how commercial space networks can shape a modern conflict. High-resolution Earth observation imagery from private companies allowed governments, journalists, and open-source analysts to monitor Russian troop buildups and battlefield developments in real time, removing the traditional shroud of military secrecy. On the communications front, SpaceX's Starlink constellation became an indispensable lifeline. When ground infrastructure was destroyed, these small, low-orbit satellites kept hospitals, emergency services, and civilian networks online. At the same time, Ukrainian forces relied on the system to coordinate operations. This dual use blurred the line between civilian utility and military infrastructure, showing that modern combat no longer relies solely on state-owned hardware. While independent analysts work to separate verified operational effects from disputed battlefield claims, one reality is clear. A private commercial operator became a central geopolitical actor. Commercial space has made military activities highly visible to the world, but it has also introduced a critical vulnerability. States now depend on private infrastructure they do not fully control. In December 2019, the United States established the Space Force, creating a dedicated military branch for the orbital domain. China executed its own sweeping military overhaul in April 2024, standing up the Information Support Force to coordinate space and cyber operations. Meanwhile, Russia maintains an active counter-space arsenal. These organizational changes show strategic priority, though restructuring does not guarantee immediate combat capability. They have, however, forced a change in how states build orbital networks. To limit vulnerability, the Space Development Agency is deploying the proliferated warfighter space architecture. By scattering tasks across hundreds of small satellites, the network ensures that losing one asset no longer cripples the entire mission. Dual-use technology complicates every orbital movement. Satellites that forecast weather, transmit data, or guide shipping also serve military commanders. Launch and servicing systems designed to repair, refuel, or remove debris can also approach and disable an active target. In January 2022, China's Shijian-21 docked with a dead navigation satellite and towed it to a graveyard orbit. This maneuver showed proximity operation capability, not hostile intent. Yet military planners must evaluate what a system can do, rather than what its owner promises. When one country defends its assets, rivals build countermeasures, triggering an escalatory cycle that accelerates strategic competition. A conflict in orbit immediately spills down to Earth. If these networks fail, transport lanes drift, emergency communications go silent, and the precise timing that synchronizes power grids and financial markets slips. While losing one satellite will not collapse global infrastructure, widespread disruption or blinding debris fields will sweep up neutral nations and commercial operators alike. Yet the 1967 Outer Space Treaty offers no protection against modern cyber warfare, mega-constellations, or non-kinetic interference. Nations remain divided over verification and defense, making demilitarization nearly impossible when national security relies entirely on the high ground. Managing this escalation remains the ultimate challenge. Next, what would happen if GPS went down during a major war? Subscribe for analytical coverage of geopolitics, military strategy, technology, and global power. Today, the high ground is no longer a distant frontier, but the fragile foundation of modern life. As nations race to secure orbit, a single miscalculation could trigger a silent crisis on Earth. The challenge is not conquering space, it is keeping our own technology from pulling us into the dark.